Hi, in this video we are going to talk about this problem. We are given an array. We need to find out length of the longest subarray that has alternating even odd elements. Alternating means it might begin with even or odd, and once it begins with an even number, the next number should be odd, the next of odd should be even, and so on. And if it begins with an odd number, the next number should be even, the next number should be odd, then even. And subarray means contiguous. The elements that we are picking, they must be contiguous. They should be considered in the same order as the original array, and then they should be alternating. Let's see this example first. We have the longest subarray with alternating even odd as 3 length. There is an even, then odd, then even. Let's see this example. In this example, the whole array itself is alternating even odd. First there is an odd, then even, then odd, then even. Let's see this example. In this example, all the elements are even. So maximum length is 1 only. You can pick either this or this or this. Now please pause this video and try to write down a solution to solve this problem. We are going to talk about two solutions. One is quadratic and one is linear. Let us see the naive solution, a solution with time complexity big O of n square. The idea is simple. We traverse through all the elements. For every element, we find out longest alternating subarray that begins with this element. And if this longest is more than result that you have found so far, then you update the result also. We initialize result as 1. We traverse through all the elements. For every element, we initialize the current length as 1 because a single element is also considered as alternating subarray. Now we traverse through elements after it, and for every element, if it is alternating with the previous element, how do you check if current element is alternating with the previous one? If current element is even and if the previous element is odd, then it's alternating. And what is the other possibility for alternating? Current element is odd and previous is even. If any of these two are true, so we have logical OR here. If any of these two are true, then we update current. Otherwise, we break the loop. As soon as we find an element which is not alternating, we come out of the loop because some subarray elements have to be contiguous. So this is how we find out longest subarray that must begin with I, right, and which is alternating. Once you come out of this loop, your current holds that length of that longest subarray that begins with array I. And if this current is more than result, then you update the result also. And at the end, once you have traversed all the elements, you return the result. That's the simple idea. Let's now see running of this. Let's consider this array. We begin with I equal to 0 from here. And we traverse through the elements starting from I plus 1, right? We initialize the current as 1 and then we traverse from I plus 1. This is alternating with the previous. So our current now becomes 2. Now we come to this, J come to this element, and this is not alternating with the previous. So we break the loop. And when we break the loop, our current is 2. And current is more than result. So we update the result also. Result was initialized as 1. Now it becomes 2. Now we move I here at this element. I is 1 now. So when you are here, you again check from the next element. J begins with I plus 1. And this is not alternating because they both are even. So what you do is you come out of the loop and your current remains 1. And you compare it with the result. Result is 2 and current is 1. So you do not update the result. Now you run the loop for I equal to 2. And this time, again you come out of the loop in the first iteration itself. When you run for J equal to I plus 1, you notice that it's not alternating with the previous one. So you do not update the result. Now you run this for I equal to 3 for this element. And you find out longest alternating subarray that begins with this. So you run a loop for J equal to this. And this element is alternating, so you increment current. Then you run the loop for J equal to this. This is also alternating with the previous one, so you again update the current. So your current becomes 3 and you come out of the loop because your J becomes n, right? You traverse to the last element. And now your current is more than result, so you update the result as 3. So we have run for this I, now we run for the next element. When we run for the next element, our I is 4 and we again check for alternating from here and this is alternating, so current becomes 2. and current is not greater than result, so we do not update the result. Now we run for the last element, and there's nothing after the last element, so our current remains 1, and we come out of this main loop, right? We come out of this main loop here, and we return the result, and result is 3. So this is how the solution works. Let us now talk about time complexity of the solution. There are 2 loops, and in worst case, this loop will also run from I plus 1 to n minus 1. So overall time complexity in worst case is big O of n square. Now please pause this video and think of a solution which is big O of n. As a hint, you may think in terms of Cadence algorithm. Let us now talk about the efficient solution, which is big O of n and based on Cadence algorithm. Like Cadence algorithm, we begin traversing from the second element. We begin with I equal to 1. And for every element, there are 2 cases. Either you begin a new subarray or you extend the previous subarray. Here, we extend the previous subarray if current element is alternating with the previous element. And if it is not alternating, then we'll have to begin a new subarray, right? So that's the simple idea. And one more important thing to notice here is, in the naive solution, we were finding all the subarrays beginning with an element. Here, we find the subarrays ending with ith element when we are at index I. Let's now see the solution one by one. So we initialize the result as 1. We initialize the current value also as 1. Now we run a loop for this from the second element from here, right? And inside this loop, what we do is we check if it is alternating with the previous element or not. It is alternating with the previous element. So we go inside this if condition, make the current equal to 2 and update the result also, because result currently is 1, right? So we make it 2. Now we come to the next element, I equal to 2, and we check if it is alternating with the previous or not. It is not alternating, so we begin a new subarray with this element, right? With the value 20. And now we come to the next element. We again check if it is alternating with the previous or not. It is not alternating, so we again begin a new subarray with this for I equal to 3. Now we come to I equal to 4, and when we come to I equal to 4, we check if it is alternating with the previous element or not. If it is alternating in this case, so we are going to extend the previous subarray by 1, and we are going to compare the result with the existing result. The existing result is 2. So we are going to extend the previous subarray. Now our current becomes 2, and we compare the current with result. The result is already 2, so we do not update the result. Now we come to this index, and we check if it is alternating with the previous element or not. It is alternating with the previous element, so we further increment the current. We basically extend the subarray. Now our current becomes 3, and it is greater than the current result, so we update the result also. Now our result becomes 3, and we stop here because this is the last element. And at the end, we return the result. So this solution is based on Cadence, works in linear time. There is a simple loop, and we are doing some constant amount of work inside this loop, and has the time complexity as big O of n.